to point out the miniature class. In this figure, we consider a problem with two classes, the the blue class and the green class. And we said that there is an imbalance class problem when one of the two classes are more representative than the other. In this case, the blue class is more representative than the green class. We name it as majority class, the class with more instances, and we label as C minus or negative class. The class with low number of instances in the dataset, we name it as positive class, labeled as C plus, or positive class. Well, this is an important problem. For this reason, the Kill software suite have taken into account the significant scenario of classification, and it includes a complete framework for the experimentation of this type of problems. We introduce some issues about imbalance learning, imbalance data sets. Um, there are several reasons behind the problem because the hit with imbalanced dataset is that standard classification learning algorithms are often biased towards the majority class, and therefore there is a higher misclassification rate for the minority class. For this reason, most of the standard learning algorithms consider a balanced training set. This may generate suboptimal classification models. For example, a good coverage of the majority examples, whereas the minority one are misclassified frequently. They, the problem or the reasons behind this behavior is the use of global performance measures for guiding the learning process, such as the standard accuracy rate, may provide an advantage to the majority class. In classification rules that predict the positive classes are often highly specialized and thus their coverage is very low. Hence, there are discarded in favor of more general rules. And very small clusters of minority class examples can be identified as noise, and therefore they could be wrongly discarded by the classifier. On the contrary, few real noise examples can degrade the identification of the minority class, since it has a fewer examples to train with. However, there are a lot of techniques that can be used to handle the imbalance class problem. We can categorize into three major groups: data sampling, in which the training instances are modified in such a way to produce a more or less balanced class distribution that allow classifiers to perform in a similar manner to standard classification. Algorithms modification, these procedures is oriented towards the adaptation of base learning methods to be more attuned to class imbalance issues and cost-sensitive learning. This type of solution incorporates approach at the data level and the algorithmic level, or at both levels combined. Consider higher cost for the misclassification of examples of the positive class with respect to the negative class, and therefore trying to minimize higher cost errors. Most of these kind of algorithms can use it in imbalanced learning models. The other model is a statistical test model. I, can, I, I think this is the most important too, because we can use this model when, when we have results and we need to use it that get a comparison between some methods, and this could provide a latex code to use it in papers. Well, for this reason, a statistical test model, uh, the goodness of a given approach can be the only measure in terms of the improvement for the mean performance. Significant difference must be found among the different algorithms for concluding the superior behavior of the one there that achieves the highest average results. For these reasons, in Kill Software Suite, several hypothesis testing techniques are included in order to provide statistical support for the analysis of their results. Specifically, we can use the not parametric test due to the fact that the initial conditions that guarantee the reliability of the parametric test may not be satisfied, causing the statistical analysis to be lost credibility with this type of test. The other model is semi-supervised learning model. For this, the semi-supervised learning, we can name it as SSL paradigm, has attracted much attention in many different fields ranging from bioinformatics and web meaning, where it is easier to obtain unlabeled that labeled data because it requires less effort, expertise, and time consumption in this context. Traditional supervised learning is limited to using labeled data to build a model. Nevertheless, SSL is a learning paradigm concerning with the design of model in the presence of both labeled and unlabeled data. Essentially, these methods use unlabeled examples to either modify or reprioritize the hypothesis obtained for labeled examples. The kill software have taken into account this significant scenario of classification, and it includes a complete framework for the experimentation of this type of problems. The next is the multiple instance learning model. In uh, this is a generalization of traditional supervised learning. In this part, training patterns called bugs are represented as a set of future vectors called instances. Each bug contains a number of non-repeated futures vectors called instants. Each bag have information about another bags, and each one receives a special level, although the levels of instants are unknown. The problem consists on generating a classifier that will correctly classify ounces bags of instants. The key challenge in multiple instance learning model is to cope with the ambiguity of not knowing which instances is a positive bag are actually positive examples and which ones are not. In this sense, a multiple instance learning problem can be regarded as a special kind of supervised learning problem with incomplete leveling information. Well, when we're running a kill experiment, we deploy a kill experiment. In order to launch a kill experiment that previously has been designed using the kill software suite, this will create a zip file that containing all the files needed to run the experiments. First of all, you have to unzip the named zip file in your computer, and this will run the experiments. This don't have to be the same computer that was used to create the experiment, but need to able to run a Java virtual machine with a latest version 1.7. You will obtain a directory called experiment name with the name. How an user naming this your experiments. Then you has to place himself into that folder. It depends you name it, and mm, and there are a subfile named scripts. This subfolder run the experiments and only use to type in a shell the Java command to run the file jar like this. The experiment is executed. With it finished, you can see on the prompt of the shell the message experiment complete successfully. There are some restrictions that must be considered when making connection between different elements. You have to consider that a data set cannot have inputs. Knowledge extraction methods can receive data from a data set or from a previous method. The graph cannot have any cycle, and these restrictions are verified in execution time when a connection is being created. Uh, and if one of these connections is not permitted, the application will show an error message. We continued with the use of kill software. Well, do you remember that in the previous class we talked about to unzip the kill file. Firstly, we can download the zip file in this page. We only to download, unzip, and we can see that this file have a lot of directories that contain some files we need to run in the disk. We need to run graph interkill. Do you remember that we have two ways to run it depending the operating system? If you have Windows, you can only click right on jar file and run. But if you have Linux, or in my case, macOS, I use the shell. For this reason, I need to stay in the path directory. I change the path. Kill. The other directory is experiments. Sorry. Okay. Experiments. Kill. List. And use the command Java. Yeah. When we use this command with Java, minijar graph interkilled, the kill software right now are running. This is the first interface that we can see. Well, we use firstly the part of educational, and in this example, if we click on educational example, we see the general interface. In this part, we have to choose we need to choose the type of partitions and the type of experiment, if depending if we have a classification or regression. And this is the area in which we can generate the graph flow. Right now, we start to use that. Firstly, we choose a careful cross-validation like that, but you can use, if depends your data set, if you have a many instances in your data set, you can use 10 or more than 10 call for cross-validation. But if you have a less number of instances, you can choose another number of careful cross-validation. Or if you have uh, mm, another kind of cross-validation, you can choose 5 per 2 cross-validation or without validation. But we start with 10 for cross-validation. And we use a classification experiment. When you click on classification experiment, Q provides us the, the kill data sets that had been uploaded in Kill software. Kill software have some pre-configured dataset, but you can upload your dataset. Firstly, we use the IRIS dataset. In this dataset, we have a multi-class problem. The classification is about the type of IRIS. We can import datasets according the type of files that Kill uh, can read. But in this case, we use the IRIS dataset. Firstly, we need to choose. If we have another problem, we need to use the new experiment. This is the icon. Well, I continue with IRIS and only click on the work area. This is the work area and click. Right now, we at this moment we have a data set selected, and we can start the flow. This icon is about the data set. This icon is the kind of the type of algorithms, the kind of algorithms that we can use with these experiments about classification. We have discretization, evolutionary, future selection, and training set selection. This is a preprocessing algorithms that we can use before classification problem. But we use only a classification method. For example, we have decision trees, evolutionary cross-rule learning, evolutionary fuzzy rule learnings. We have neural networks, example. Well, well, in this part, is depending on which icon you can click or you click it, you can see that these files change. Well, we use a decision tree to classify the IRIS dataset. Okay, we click on the algorithm. After that, we need to click on the work area. By this way, we can see that we have two icons in the area, in this area, the data and the algorithm. If we click in the row, we can connect the flow. We can uh, develop the graph. At this point, we connect the data and the classification algorithm. If we click, or if you remembered the icons in this menu, we can use this for save the current experiment, this for open an exciting experiment, and this for run the experiment. We click the run experiment, and this icon open another window. Well, we can start the experiment. This window have two areas. The experiment management, and this only we start with some data about the time, the final time to run the experiment. We can see the data set that had been used in the experiment, and the report area. This is important because we can see that per each partition, because we use 10 fold cross validation per each partition, we obtain a percentage of success, the accuracy. And the total, this is the total percentage of success. This part is about the training, but we have the test. We have two partitions. The training, the training partition is about instances or examples about our dataset that had been used in the classification experiment. In this moment, we use a supervisor learning. The supervisor learning is about when you know a priori the class about one instance. Well, if we know the class a priori, we use in training partition, but when we use a test partition, the classification algorithms ignore the class to test the classification algorithm. Well, and the same way, we have 10 partition in test and a total percentage of accuracy. We have the confusion matrix. We know that rows are real class and columns is the predicted class. And if you remember a confusion matrix, the principal diagonal is mean that this number are the corrected number of instance classified as the real class. Well, after that, we have the model generated. This is uh, dependent the kill because have uh, an a property kind of attributes. Firstly, we have the description of the attributes in your data set. After we have the decision tree because we use a decision tree. This is a decision tree like an if else. It depends the node in a graph. If we have in a node the petal width, and it depends if the petal width we can path to the class iristosa, or we need uh, to another attribute. For example, this the unique attributes that had been used in a decision tree is petal width and petal length. It depends the lana width. We can choose the class. This is the decision tree. And some issues about decision tree is total number of nodes, number of lefts, total number of nodes, and number of antecedents by rule. Well, this is an educational experiment way to use with kill. These kind of experiments in educational don't have a zip, don't have a zip file because this only used to use in the same computer. But if you need to use another computer, we need to use the other kind of experiments. We can close. You can save the experiment. If you can say yes, we need to choose in which directory need to save the experiment. In this case, we create a new folder. Like an example. And the name of this example is example 1, and only click and save it. And kill create a folder named example in which we use an Excel file that have the configuration about the experiment. If we use educational, if we use file and load experiment, we can choose the last experiment that create. Sorry, this is not the correct because we can use experiments. Right now we use experiments. It's similar that educational. In this way, we can use code for cross-validation. We can use another type of experiments on supervised learning or subgroup discovery. We continue with classification experiments and kill use the same data set. We can use the wine data set. In this data set, we have the quality of the wine. We have around 5 class to the quality. Theoretically, the quality must be 10 classes, but at this moment, some data set only have 5 classes because The thing is there are not um, examples with the top classes, and there are not examples with the lower classes. We click on the experiment area. After we choose the dataset, and at this point, do you remember that uh, we have um, more icons in this kind of experiments and experiment design? We have statistical methods that can be used in this at this point. Do you remember? If you don't remember, you can see that this is about the data set. This is about preprocessing algorithms. Like if we have missing values, we can use commands to use to field missing values, to remove missing values. It depends what kind of algorithm choose. If you if your data set have noise, you can use a filtering algorithm like Panda or like saturation filter. This kind of algorithms remove the noise in our data set. Oh, or if you have a lot of attributes in your data set, you can use a filter selection to don't use all the filters. For example, you have 1 million on attributes in your data set. That is a big data set. You can select an algorithm to select the attributes, the more important attributes in your data set. This is the algorithm to preprocessing. The icon, sorry. But the next icon is the classification algorithms. We can use, for example, in this kind, we can use statistical classifiers. We can use lesson learnings. In this kind, we use KNN. This algorithm is about the neighbor clauses. The key, the key number of neighbors that has been closed to another instance. We use this algorithm to classify the wine dataset. The next section, if you remembered, we can uh, use it to convert, to use a statistical test for classification and show the results. For this example, we use this classification statistical like Friedman. If we have more than one classification algorithm, or you can use a Wilcoxon. But in this case, we use only show results. We need to use class check. Only click on class check and click on area, and that's all. If you can see the regression is unable because we choose a classification experiment. We need to use the row to build the graph. We only use the row, click on the icon with data, and click on the icon with the class. And the next, click on the classification algorithm and click on uh, the final view. We can move the icons to click on this icon. We can move it. And if we need to remove some of that, we can delete because I click on the classification we need it. But for example, I use another kind of algorithms, and we can select another and click on remove. All right. Well, we do you remember the restriction conditions that I mentioned before? That the graph uh, don't have or can't have any cycle because I can't draw it. I can this connection is not possible. I can the data can have inputs. Well, if we click, if we twice click in this icon, we can edit the parameters. For example, we use the nearest neighbor classifier. The default value of the number of neighbors in this algorithm is 1, but we only click in the value and we can remove it and modify it. For example, by 2 neighbors. And we can change in this algorithm the distance function like Manhattan or HBDM, but we use Euclidean. We can restart the values, and this is applied to all the data, but you can,
Angelica. Hola. Hola.
oh, Hola, hola.
Sí, puedes continuar.
Thank you. Sorry for that. Well, uh, the last thing that I said is about take an screenshot uh, if you need to share your graph, you can take the screenshot with kill and save it in wherever you want to. For example, I use my folder example and name it SZ1 and save it. And kill software, take an screenshot and save it like an image. Well, the most important thing is we can save the experiment and we can play and this run the experiment and kill save the experiment and all files that had been necessary to run the experiment in another computer. We click on this icon like zip. After that, kill software, save the experiment. We need to save with a name, example, experiment one. We can choose the folder, the path that you need, and only we put a name and click on save it. Kill software uh, use a message that the experiment has been created uh, in a zip file, and the kill software say that you go to experiment 1 script directory and execute java jar run kill. The kill software uh, say the right command that we need to use to run the experiment in this computer and on another computers. We only click on OK, and that's all. To run the experiment in this computer on another computers, we open the folder and we can see that we have one folder named an experiment one dot zip that we only unzip I unzip the folder. After that we can see that kill provide the the data set that we choose firstly, the one with all partition, training and test, and we use the 10 for cross validation. We have 10 partition about training, 10 partition about test. We have another folder with execute with the classes that use kill with the classification algorithm and the last with class about uh, the final results. We have the scripts. On scripts, we can see the run kill yard, the run kill file that we need to execute on a shell. And results. Right now, we don't have any file about results because we don't execute the run. Well, for this reason, I open a new shell. Right now, I need to move into the scripts folder. And if you have Windows, you only click on uh, double click right to run the Java file. But if you have Linux or Mac, you can use the pad to move in the shell. I move to desktop example, and in this case we use experiment one. Experiment one. I need to move to scripts and only use Java minus jar run kill dot jar. We only stay to the Java machine learn used the all the files to execute the experiment. After that, we need to see like that the experiment complete successfully. If if have an error message, the error message said express the what is the problem about the error. But in this case, we have a successfully experiment. Right now, we have in results the results completed. In this, we can see in via class check the results. We can see that is a particular kind of file. I use Sublime to open this file, but you can use another software, another app to open the file. And if you remembered, the educational experiment is more like that because we have the results and training results, and we have the accuracy about classification. Well, in this, we don't have the confusion matrix because Kill don't provide it, but you can create your confusion matrix. Well, I close that. And if you see the CNN, you can see that per each partition have the confusion matrix. It depends the partition, and we can see the accuracy per each partition. Well, for this reason, I say that we can build the confusion matrix, the general confusion matrix, but use it each file. Well, This is for each partition. Well, we close that. We close that. I don't close that. Well, we can close that. I don't save. No. Well, we need to another exercise about how to upload own data set on another data sets. For this reason, we use uh, data management. If you remember, I provide us a link, a short link, in which you can find some mm, you can find some files, the slides, and two more files. One of that is about a data set, another is about a, a kind of data set, but we use with a statistical test. We need to please download the chemical composition of ceramic file. I only use to move it in experiments. Well, if you don't have a data set, I provide you some web page in which you can find um, a lot of data sets. You can use scale. In this website, you can find different data sets. It depends uh, your issues or uh, your topics. You can search about obesity, for example, or about another uh, terms. You can use UC machine learning repository, and you can see the most popular data set is it is adult wine quality, rice, card, or you can use data set search. You only type uh, keywords like chemistry, for example, and you can see that there are a lot. You can explore. You can see different websites, and you can download the data set. But in this case, we use the chemical composition to import the data. I close. We use data management. We use import data. We click on import data, and we move to the path in which the data set is. I select the input format. In this case, we can see that we can use CSV, TXT, an Excel, a Wika, an XML, a database SQL or another killed file. We use CSV file. We can use options. It depends if the separator is different from the comma. You can change it, but not because the dataset use a comma. If your dataset have an attributed name header, click it or not click it. In this example, if you open the file, you can see if this file have or not the, the header. In our case, we have a header. This is the header per each column. Well, for this reason, we click on attributed name header. We choose the chemical composition of ceramic. We click on next. And right now, in this part, we can see all data. And this part, we can see the format key. In this part, you can see that the first, this is about the name of the data set and the name of each attribute. And kill can identify the range and the type of the type of data. In this case, the attribute is about real, is about integer, and this identify the class. The class is outputs. In outputs, this is the attribute P205 with integer. And this is the, the complete data. We only use save. We only click and import to the experiment section. This is important to click on import to the experiment section and use save it. We rename it because I use a short name. Only okay. And in this moment, we need to select what is the type of problem about this data. In this case, we use classification. If you want to edit the data, for example, click on yes. For example, add more instance, you can click on add instance. But if you can delete instance, only click on the instance and delete it. Well, you only and save. You save that you can change the name or not. In this case, cancel. I can close this part. And if you have import partition, you only click on import partition. If you need to export the data, only click on export data and choose the path. You can visualize the data, in this case, I need to use on kill experiments, kill. In this case, we use on resource, sorry. We can use the data, or we can visualize the attribute info. In this case, sorry. We can use all files. We can click. We can open. If we can open all the file, in this part we don't have attribute info because this file is not on kill format. For this reason, we can see the charts. We can edit, we can use a partition and that. But I use the last data set. We use for cross-validation, we use classification, and right now we can see that we have the new data set. In this part is chemical. I only click here, and because when we have the first time and we select 10 for cross-validation, kill say me that the data set don't have this number of partition. Do you want them to generate? I say yes, and automatically killed create the 10 full partitions. Well, we use uh, the same. We can use another algorithm, but we can choose a decision. For example, we can choose. We can choose. Cannot choose clustering because it's about a classification and supervised learning. In the reason we have, uh, we know a priori the class. We can use some neural networks, kill, identify the type and the kind of data, um, enable and disable uh, the different kinds of algorithms. Well, we can use a decision. For example, we use, for example, another decision tree. I use show results via classification. I use a row to connect the data with the decision tree. We need another row to data. Okay, this is important because have an interdata and destination. This kind of algorithm don't use it, but we only remove it. We can choose a neural network, for example. We can connect. This is the same. Don't accept not noise. We can remove it. Well, and we can connect via class. We can use the init. In this case, we can, I only need to click on this to click, and we can change the default values, but I can change only this. I change by 2, apply, and only check that. Ah, this is important because we need to use a via class check per each algorithm. Yeah? In this case, we only use a via check per each algorithm. But we can save. I save an example 2 and save it. Okay, that's all, and it's the same thing. You need to put on the path on your shell and run the kill. You need to unzip first, or you use the zip in another computer to unzip and execute the Java jar. We don't save. Right now we use the modules, and specifically we use a non-parametric statistical analysis. We use the file medias. If you have uh, an experiment with some results and only you have to use the statistical analysis, you can use kill. This file have um, a different type of data with different method. The different method used per each uh, a data set. We have an accuracy percentage per each method, and we use that data set to execute not parametric statistical analysis. We choose not parametric. You can type uh, all data. You can change from that only with double click on each. You can change it, but we use a file. For this reason, we only load a data. We choose the data and open, and automatically the data set successfully loaded. It is loaded, and you can choose the statistical procedures. You can choose all. No, you can choose one. In this case, I use a Friedman test 1 per n, but you can choose all of that. All of us have done methods, but it depends what do you want. You can use the performance measure about maximize or minimize. In this case, we need to uh, obtain the best method. For this reason, use maximize. And only we use perform analysis. We click on perform analysis. We need to choose in which file, the name of file. In this case, I create a new folder named statistical analysis and create. And into this new folder, I create free and only save it. The file format is a text file, a latex, and save it. The results I save it, okay. Uh, I can use a Wilkinson test. You can click on Wilkinson and save it and perform the analysis in the same folder, but use Wilkinson and save it. Okay, I open this file, and for example, you can see that Kill create text files. In this example, in this case, we can open, we can execute it, and we have a, a report with the algorithm and the ranking. In this case, the Friedman test. This is the average ranking of the algorithms. In this case, this is the algorithm and this is the rank. We can see we have the post-hoc dog comparison Friedman. It depends if you need it. And the adjusted p-values. You can see we have a Wilkinson test, only open, running, and you have the results about the Wilkinson, the confidence intervals for median and difference, and some details about the methods. This is, I think this is more useful because you can only take some course of LaTeX about the statistical experiment. And the last one is the Wilkinson summary, in which we can see the rank or the ranks. And that's all about Q. Uh, Sorry for the time. I think is all. We can only exit and close it. Uh, for the time, I think that's all. Sorry for the interruption. I don't know if there are questions.
Angélica, ¿podremos hacer aquí para que la gente pueda ir al coffee break, tú también, a descansar? El link de YouTube estará abierto para que la gente pueda poner sus dudas y tú puedes contestarles o entrar en contacto contigo. ¿Te parece bien?
Sí,
Pues nada, perfecto. Bueno, la comisión organizadora del CIDMOL agradece muchísimo a usted por esta contribución, por aceptar nuestra invitación y estamos en contacto y que en el futuro podemos encontrar personalmente y que puede estar con nosotros aquí en persona.
muchas gracias. Gracias por la invitación y a todo el comité. Gracias por su tiempo, por su
Nada,
disposición. Gracias.
que tenga un lindo día en México, ¿vale? Muchas gracias.
Gracias.
Hasta luego.
Igualmente. Hasta luego.